Okay, in this video I'm going to show how I'm using an Atmega328 on a breadboard to make an Arduino compatible circuit. My power supply lying around is an output of 12 volt, center pin positive, and I need 5 volts for the Arduino or the Atmega328P. This is a common circuit which I found at extremecircuits.net. It uses the 7805 regulator IC and 3 capacitors to make the circuit. These are the components. I'm going to add a little LED and a resistor to show that the power is on the output, and also a little barrel jack to take my plug from the AC/DC adapter and some header pins. Break off 3 header pins and put them in the breadboard, and then take the socket and solder it onto those pins. You don't need this third pin for an electrical connection, but it helps to stabilize the socket in the breadboard. The center pin is positive, this pin is ground, so that goes to your ground rail. You'll see on your input you've got C1, which was the 100 microfarad capacitor, so that goes between the input rail and ground. Observe polarity on the cap. Then the positive we've transferred to this rail, which goes to pin 1 on the IC. The center pin on the 7805 goes to ground. And then the third pin, this is the back, so this is the third pin, goes to output on the positive rail, 5 volt rail. And we've also got the C2, which is the 10 microfarad cap between the output and ground. And we've also got the 100 nanofarad cap in output and ground, and I've left the line open for the resistor for the LED indicator, which goes from there to the center pin, which is ground. And I've used quite a high value. You can just Google resistor values for LEDs, so that my LED is not that bright. And there, if I plug in my AC/DC adapter, the light does come on, all is good. Then on the other side of the breadboard, I've transferred the power connection from this rail to that rail, and the same with the ground connection. These are the parts I'm going to use for the actual circuit. Atmega328, 16 MHz crystal, 200 nanofarad caps, 22 picofarad caps, a 10K pull-up resistor for the reset pin, and a reset button, momentary push switch for manual reset, LED and a resistor for the LED, a 2x3 6-pin header box for the in-circuit serial programmer, and a piece of strip board and some header pins to convert this to go onto the breadboard. First you cut a piece of strip board like this, and in the center you break the strips so that this half is not connected to that half. You take 2 pieces of 3 pins and you push down the pins so that they level there, and you put them through the strip board and you solder them. Then you put the header box in and you solder that as well. And then you've got this adapter that can go onto a breadboard. On the cable that goes in there, this protrusion together with the arrow on the line indicates pin 1. So this is pin 1, and I've just marked it there on the strip board. The chip has got an indent there and an indent there to indicate that to be pin 1. So we've got the pins marked 1 to 14 and 15 to 28. One of the layouts I like is on hobbytronics.co.uk. Gives the actual pin numbers together with the equivalent Arduino pins. So the yellow ones are digital 0 to 13, and the pink ones are analog 0 to 5. And it also has got some other descriptions of what the pins are used for in the Arduino environment. So we start at pin 1, which is reset. So we put our 10K resistor between reset and 5 volt to pull it up. Then we've also got it going through the push switch to ground, to pull it to ground when we push it manually. Then if we look on here, we see that the chip needs power on pin 7 and 8, so 7 goes to 5 volt, 8 goes to ground. Then we put in the 100 nanofarad capacitor between 7 and 8 for decoupling. On the other side, we've got the reference voltage also on 22 and 20, so 22 goes to ground, 20 goes to 5 volt. And put another 100 nanofarad cap there for decoupling. Then on pin 9 and 10, we've got our crystal oscillator. And between the two pins of the crystal, 9 and 10, or from each one, from 9 to ground and 10 to ground, with the 22 picofarad caps. Then we put in our header box there. The layout on the header box is pin 1 is master in, slave out, 0 o'clock, reset, voltage or 5 volt, master out, slave in, and ground. You'll see that pin 1 is master in, slave out, which goes to pin 18. So we've got pin 1, which we marked here, going to pin 18. We've got pin 3 on the header box to be serial clock, which is pin 19 on our chip. So 3 goes to 19. And then pin 5 to be reset, which is pin 1 on the chip. So we've got that one going to pin 1. Then we've got pin 2, which is voltage, which goes to 5 volt. Pin 4 is master out, slave in, which is 17 on the chip, so that one goes to 17. And lastly, we've got ground, pin 6 going to ground. Then I want to add a LED on pin digital 13, just like the Arduino. And we see digital 13 is pin 19 on the chip. So we've already used this connection for the header box. So we can just put a resistor in there, and then connect up our LED to be an indication on pin 30, digital 13 on the Arduino. And that completes our circuit. Thank you for watching.